So, hello everyone, and good morning, and welcome to today's morning session. And this is going to be our introductory session on a new online short term course that we are starting related to design and detailing of structural steel connections using Idea Statica, MS Excel spreadsheet, and manual calculations. So again, I welcome those who have joined us live and also those who will be watching this stream later on YouTube. So before I proceed, I hope the voice is audible to everyone and you can see us and you can also hear what is happening. Okay. So let us begin then. I hope we had a wonderful start with a very melodious music piece created by A.R. Rahman, which we were listening to. So, with that wonderful rendition, let us begin. And I'll share my screen, and we will start with our session straight away. So, yeah, I hope this presentation is visible to all. Okay, so this is our introductory session, as I had mentioned earlier, and we will see first the agenda. So, this is how our presentation will flow. It will be around 30-35 minutes presentation, and then we will have your queries. As you have noticed that you are all watching live or you are watching on YouTube, so if you want to ask any questions, the way to ask questions is to type it in the comment section. Okay, and we will take your queries and we will try to answer them. Okay. So just type in whatever your questions are in the comment section, because you are on YouTube, so you cannot unmute yourself, or there is no other way to uh, resolve your queries. Anyway, so this is going to be the agenda for today's session. Why structural engineers are not confident of steel design or connection design? Then why did we think that this type of a course should be conducted? Then a few things about AuxEn and our consultancy KCEPL. Then our evolution over the past 4 or 5 years, and what impact we have been creating for our participants. A few things about us. Then we will move to the important parts, that will be the details of the course, the features, who will benefit from the course, what is the outcome that we are looking at, how to proceed ahead, and we will end with your queries. So don't worry, all your queries will be answered too. Good. So why are structural engineers not confident of steel design? So most of us are not very, I would not say good, but we sometimes feel underconfident or overwhelmed by steel design, and that is true not only for steel design but also for connection design, because connection design is a part of your steel design. Okay, so this problem mainly starts at our undergraduate or postgraduate level, where it's usually seen that the subject is not properly taught, and the books and the documents also that you have on steel design, they are mostly covering the theoretical aspects, but the practical aspects, or what you would require if you are working uh, as a consultant, or if you are working at some design firm, those aspects are not covered. Many structural engineering firms, many structural engineering companies, many civil engineering design companies also mainly do RCC projects. So, as a structural engineer, as a civil engineer, you are not able to get the on the job training also. Okay, because most of the companies are involved in doing just RCC projects. So, what happens these days, that many structural engineers either have to rely on standard practices, or they have to give the project to someone else, or these days there is a new trend to give the project to a pre-engineered building company. So your headache is gone, and you just give the project to a pre-engineered building company. So that is the trend these days, and it is mainly because we are not quite sure how to do steel designs. Not on, and of course, when I talk about steel design, it will also include the connection design, because connection design is a part of important part of steel design. So why this course we are conducting specifically on connection designs? So because of all these problems that I mentioned, we through this course will try to have an in-depth understanding of design and detailing of structural steel connections. So all of you understand that steel connections are a very important part of any steel structure. Most of the failures that happen in your steel project, they happen due to failure of your connections. Okay, so connection design, if I could just write it over here, connection design is very important when it comes to your steel projects. Okay. So, through this course, we will provide a great mix of learning, and we will cover or we will have discussions through detailed manual calculations, because what is the use of a structural engineer or a civil engineer who cannot do manual and hand calculations properly? So, we will do all the discussions through detailed manual calculations. We will verify them on Idea Statica software, and we will also prepare MS Excel spreadsheets, including their development. So not only we will give you ready-made Excel sheets, but we will also discuss their development. Development means how to create those spreadsheets. So through this course, this is the three-pronged approach that we are planning to adopt, or we will adopt rather. And in because of this course, we hope that the participant is able to understand the structural steel connections, imagine the structural steel connections in a new light, and realize what possibilities lie. So that means, if you understand, if you are able to imagine a structural steel connection, then you will be able to develop new connections, or you will be able to develop efficient connection systems also. Okay, because in connections there is often the case that you have to think out of the box, and then you have to come up with a solution which actually matches with your site requirement. So through this course, this is what we are trying to do, and therefore we thought that such a course should be run. Now, before I move ahead, just a few things about our consultancy firm, that is Kutumble Consultants and Engineers Private Limited. So it's an ISO 9001 2015 certified company, and we are mainly involved in industrial projects, infrastructural projects, commercial and residential. We do not much, but yes, we do them. Warehousing, logistics, we do a lot of design development. That means a lot of design experimentation work, the type of work you do in your thesis or dissertations projects. Those types of things we do in our office, developing new structural systems or developing with new materials, etc. Other than that, we do peer review, third party expert reviews, repair and retrofitting works, forensic engineering, and project management consultancy also. So you will see that we do a lot of multidisciplinary civil engineering, structural engineering work. In addition to this, this is AuxEn is our platform for skill development and training. So me and my wife in 2015 had established this, uh, and we were involved in offline trainings first. That means we used to conduct trainings in our offices, and then so those used to be typically 2.5 months training, where we used to call participants to our office, and in morning for 1.5 2 hours we used to take sessions. So this is what we did for about 3 4 years, 3 years I think, and then after the pandemic we had to move online. Anyway, so before I move ahead, some of the type of projects that we undertake as a consultancy firm. So you will see some industrial projects, you will see a residential bungalow also. I included this bungalow because this is a uniquely designed bungalow. Other than that, you will see industrial cement plants and agro storage projects. We do a lot of we have done a few projects which are quite renowned. So if you see this bridge over here, this has been designed and conceptualized by us. This is at Haridwar. If you any one of you happens to visit Haridwar, they will see this at the main Har Ki Pauri. Other than this, I'm only showing some projects that I like, some what signature projects that we have done. So this is another project where we have submitted this proposal at for a bridge on river Narmada. So this concept has been submitted, but the project is yet to start. So this is again a steel structural bridge project, but this was for road traffic also. Some other concepts that we have proposed. This is another concept, a bridge in the form of wave. Tarang, we are calling it Tarang Setu. So this is again a concept that we have submitted for proposal. These are some of the sessions that we used to conduct as part of our offline training. So you will see some images of our office, some images in the, I think, educational institutes, and where we are training the participants. I think some of you who are joining us live today were a part of those offline trainings also. Yes. Some pictures of the sessions or talks, lectures conducted. So till now, we have conducted around 14 and 317 short-term online courses. And in addition to that, last year we were, I mean, this year we conducted the full-time online training programs, SDC 1, SDC 2, where we had, I will talk more about it later. So till now, since we have moved online, we have had a wonderful experience of conducting online courses. Our participants are come from across India, and we have had participants from the Indian subcontinent, other countries of the subcontinent, that is Bangladesh, Pakistan, Nepal, Sri Lanka, Bhutan, and plus we have had participants from the Middle Eastern, West African, South African, and East European countries. So our participants are always a great mix of graduate, postgraduate students, research scholars, practicing professionals, and uh, practicing consultants and faculty members. So you will see it's always a good mix, and therefore we are able to have good discussions during our course, which results in great peer-to-peer learning. So we have had a great experience. So over the, as I was telling you, over the 4 5 years, what we have realized that learning is about progressive unfoldment and self realization. Progressive unfoldment means slowly you understand what to do, right? You do not understand everything, or the light bulb does not shine on day one. You understand slowly. You uh, realize what needs to be done over a period of time. Okay, so learning is all about progressive unfoldment, and also it's lot about self realization. That means you will only learn when you do. You will not learn when you listen to, or you will not learn when you read anything. You will only learn when you do it yourself. So over the years we have understood this, that as structural engineers we require both these things. Okay, so we require strong theoretical base with good software proficiency. This is also what we require. So you cannot say now that you don't like softwares, or you take lot of pride in doing calculations manually. Yes, it is okay that you know manual calculations, or it is good that you understand uh, things as they are, but still you also need to have software proficiency. That is the need of the day. And not only software proficiency, but and not only strong theoretical base, but you also need to have experience of doing actual projects. Because what is the use of being a structural civil engineer if you don't have the experience of designing actual projects, correct? So to address this, over the years we have developed a two pronged approach, or a two-headed strategy, that we conduct some short-term courses like the one that we are going to conduct now. So the intention of conducting short-term courses is to build a strong theoretical base. Okay, as I said, there is no use of a structural engineer who does not have a strong theoretical, strong understanding of is or international codes, and good proficiency using software. So To address this, we conduct short-term courses. They are typically 60 to 90-hour courses. We are calling them short-term, but if you see, they are almost equal to a semester of studies that you have for your courses in the undergraduate or postgraduate level subjects. If you look at it, a subject that you will take at undergraduate postgraduate level over a semester, it will hardly last for 65 70 hours, right? So all our courses range from 60 to 90 hours. We are calling them short term, but they are pretty comprehensive, and they provide a great learning platform. So we have taken 17 such courses till now, and 8 out of which are available to be taken as self-paced courses online. Many of you have taken several of those courses in the past. So this is the first strategy, and the second approach for building the experience of doing actual projects is to conduct the structural design center programs. So as I was telling you, in these programs, in this year 2022, we conducted two such programs. One was a structural design center program on RCC projects, where we did 4 RCC projects, and the other was on structural design center on steel projects. So here also we took 4 projects, and in this program we cover everything from we cover everything in a way that you would in a actual structural design office. Okay, so, and this is intense. This the structural design program on steel, we are about to finish it after almost 200 or 250 hours of discussions. So it is quite intense. We do actual projects, uh, and actual big scale projects, not small 4 column 4 beam type of projects. Actual big projects we do. So this has been our evolution over the past 4 5 years. Before I move to the details of this course, let me just try to present this survey that we usually take for our participants. So we call it our impact assessment survey. Okay. So in our courses that we conduct, we ask our participants after they complete the course to measure themselves. So it's a self-assessment survey. So we ask our participants to measure themselves on these 5 parameters. Okay, so through our online courses, we are trying to address these 5 parameters: software proficiency, conceptual understanding, understanding of IS and international codes, work performance in the place where they are working after taking the course, and whether or not the course helped in job search. So we ask our participants to fill this survey after they have taken a course, and then we have plotted some graphs. So I think all of us are engineers, we will understand these quite well. So this is before taking the course. These were the average assessment by the participant. So on an average, participant said that out of 10, they had a software proficiency of 4.81, which increased to uh, a software proficiency of 8.53 after taking the course. So that means you could say from 48% to 85%, they thought that their software proficiency increased after taking the course. Uh, Impact in code understanding. So they were, let's say, at 5.75 points out of 10. This was their self assessment in understanding of the code before taking the course, and after they thought that now their understanding was on a scale of 10 at 8.5. I think you are able to understand the graphs. Our impact in conceptual understanding, so not only Indian standards but also in the conceptual understanding. I said because strong conceptual understanding and theoretical base is very important for structural engineers. So this increased from an initial 5.21 to 8.66 after taking the course. What was our impact in the job search? So many of our participants who are searching jobs, they get a lot of help from our courses. So a majority of 49% said that the courses help them in their job search. 20% said that they had not got any help yet, but they were sure to get help when they apply in the future. 31% of our participants had already jobs and they were not looking for one. So in job search also, uh, we have made positive impact, and our impact in participants who are pursuing their studies. So let's say if you're pursuing your post graduation or any other studies, then most of them said that they had good impact. They had positive impact after taking the course. So you see, we are able to have multi-dimensional impact for our participants. Okay, a few things uh, about us, and then I'll just move ahead quickly. So I think by now you must have realized that I am Ashutosh Kutumle, and I have done engineering from Indore GSITS. It's a 70-year-old reputed engineering college of Central India, and masters I have done from IIT Roorkee, and then I have been involved in structural design of various types of projects structures. For 2.5 years, I was working at Dar Al Andasa in Pune. You might have heard about it. It's a big multinational consultancy firm having their offices in Pune, Cairo, Beirut, Dubai, etc. So I worked there for around 2.5 years, and now since 2014, I have been working with our consultancy firm, and over the past almost 7 years, we have been conducting these online courses. These training programs. And on your left side, she is my wife, Akanksha. So she has done her engineering from Kota and masters from IIT Roorkee. So that is where we met. So she has rich experience of working in different multinational consultancy firms. So she has worked at ACOM, Delhi, and then she has also worked at Dar Consultants. And since 2014, she has been uh, working in our structural consultancy firm. And of course, she is involved in trainings and other activities. So, good. So now we move to the important section of our discussion, and let us see the inclusions or the course content in the structural uh, steel connection design and detailing course. Okay, so this course we will cover, as I have already told you, that design and detailing we will cover through manual calculations, Excel spreadsheets, and the software. So the detailed course contents, let me just tell you. So we will start with understanding of connecting elements. Okay, which are the two connecting elements that you now see? So either you see bolts or you see weld. Okay, you don't see rivets now. I don't know why books still continue to teach rivets. There are no rivets now. Okay, so these are the two basic connecting elements. You have the bolts and you have the welds. So that is what we will start with. And in all these connecting elements, of course, we will discuss about the type and grade of bolts. We will understand how to calculate their capacities, because unless you are able to calculate the capacities, you will not be able to develop a connection or understand the behavior of a connection or a working of a connection. So we will do this. We'll start with bolts, then we will move to welds, again where we will discuss the type and grades of welds, capacity calculation of welds, and how to use welds in connections. Okay, so these will be the two starting topics in our course. I had written about it a few days ago also, but I often wonder why connection design is taught before member design in steel books. Why connection design is taught before member design in books? Has anyone wondered this? And it only happens in structural steel books. I think only in India. Textbooks I am talking about. Yes, anyone has thought about it? Connection design should come later, right? First, you should understand the member design, and uh, then you should be discussing, or then you should be thinking about the connection design. But why connection design comes first in steel textbooks is one thing that is not quite clear to me. In fact, even if you look at the code, the connection design comes in section 10, and the member design is already covered by them. So member design in Indian standard IS 800, it comes in section 5, 6, no, section 6, 7, 8, and 9. So these four sections cover the member design, and section 10 covers the connection design. It's only in the Indian textbooks that we start with connection design for some reason which is not yet clear to me. Mr. Asif is saying the screen is blur. Is anyone facing similar issue? Blur screen? Or are you able to see the presentation properly? Okay, I hope the presentation is visible. Yes. So I am assuming that it is visible properly. Okay. So we will start with bolts, connecting elements. I'm calling it as the connecting element. We will see the type and grade. We will calculate the capacity, and we will understand the use of bolts in connections. Then we will go to welds. Of course, before this, I think I have missed a point over here. We will also understand about the basic behavior, and we will have a discussion on the basics of different types of connections. So actually, this will be our starting point, understanding the behavior. Okay. This I meant I think I forgot to mention. So our course will start with understanding of the basic aspects of a connection. Then we will move to the connecting elements. So that is bolt and welds. These are the two connecting elements which we adopt. Once we discuss this, then we will move to the connections. So we are moving from part to whole. Okay. So first we have discussed about the connecting elements, and then once we understand the connecting elements, then we will start understanding connections one by one. So we will start with beam to beam connections. In beam to beam connections, we'll discuss beam to beam shear connections, beam to beam moment connections. Now some of you may ask how to develop beam to beam moment connections, because if you know steel design, you will understand, or if you have worked on structural steel projects, you will understand that it is difficult to develop a beam to beam moment connections. Okay, there are problems in that, but we will see what to do with this issue. Okay, then we will go to, just a minute, I think, just hold on. I think one of the aspect is missing over here. So allow me to just give me a minute. Yes, actually, I think in this presentation, one of the topic is missing. So I'll just go to a different file, and let me just open it. Yes. So what I will do is, actually, that in that presentation I saw that there was one thing that was missing. So I'm just going to share a different presentation with all of you. Yes. Can you see this? I hope this is visible. All right. So as I said, we will start with the various understanding the various types of structural steel connections and load actions. Then we will go to connecting elements. So connecting elements will be bolts and welds. Then we will go to beam connection. Up till here we had discussed in beam to beam connection, the beam to beam shear connection and moment connection. This is slightly difficult to develop, but we will see what to do about it and how to do about it. A beam to beam connection would mean that this is my beam, let's say, and I want to join a beam like this maybe. Okay. And in this type of connection, I want to develop a shear connection or a moment connection. We'll see how to do that. Then beam to column connections, very, very important. So beam to column shear connections, beam to column moment connections. Then we will go to stiffness classification of connections, which you find in annexure of IS 800 also. So there is a stiffness classification given for your connections in IS 800, but that is slightly difficult to understand. But we will still discuss it, and also we will discuss the stiffness classification as per EN uh, EN 1993 part 1 8. Okay. So we will go to this code also for understanding the stiffness classification. Based on that, we will discuss about the beam to column, rigid and semi-rigid connections. Again, very important conceptual understanding is needed for this. So we will discuss about it. Then we will go to the bracing connections. All of you know where you are able to see bracing connections. So we will understand the bracing connections. This bracing connection we had included after we got input from our participants that you should also include the bracing connections. So you might have seen braces X bracing, or you might have seen braces as A bracings. So all these bracing connections over here we'll try to address. Okay, different types of bracings, how to develop their connections, we'll try to address that also. Splice connection. Splice means your steel members have a finite length. So if you want to join two steel members together to develop a connection, then that is called as a splice connection. Just like we do the lapping of reinforcement in a RCC, similarly in steel, we develop a splice connection. So then we will go to understanding of splice connections, and there is some important clauses given to you in IS 800 for design of splice connections. So we will have a look at the general column to column splice development and beam to beam splice connections. Then we will go for design and detailing of column base plate connections. Again, very important, because this is where your steel structure ends and you put it on some RCC. Okay. So column base plate connection is what we will discuss next. And in this, we will discuss about the column to base plate shear connection, then column to base plate moment connection, and development of actual pin and roller connections. Has anyone seen actual pin roller connection anywhere? Has anyone seen any actual pin roller pin connection anywhere? Okay, if you have not seen, if you happen to visit airports these days, you often see this type of a connection where you have a member connected like this. I don't know if you have observed it or not. So in airports, you see this type of a connection. This is an actual pin. This is an actual pin connection that you get. So this is also we will discuss how to do some quick hand calculations for this. We will be discussing it. Other than this, we will discuss about the ductile design and detailing of connections. So we will have some discussions regarding this. Why this becomes important? Because if you go to the section 12 of the IS 800, or if you go to the newly uh, published draft on the ductile design and detailing of uh, steel structures, just like IS 13920 you have for RCC, there is a similar draft for ductile design and detailing of steel structures. So in that also they have talked about the connections and how to ensure that they provide enough ductility without any brittle failures. So I will throw some light and we will have some discussions on this also. Now, when we are talking about connections, we need to understand that which members we will be taking for our connections, right? So, because it actually depends on the type of member, your connection will depend on the type of member, right? So, what type of members we are going to take for our discussion? So, we will take the normal three plate section. That means a section like this. This is our three plate section. I'll discuss the connections for these types of members. So these are my channels, angles, okay, and ISMBs. So for these, we will develop or discuss connections. When I'm saying we will take these members, what I mean is that see these are our connection types. A beam to beam connection is my connection type. A beam to column connection is my connection type. A bracing connection is my connection type. Let me just clear the screen uh, to show you some more things. How to clear the screen? Erase all ink. Yeah, good. So these are my connection type: a beam to beam connection, a beam to column connection, bracing connection, splice connection, column base plate connection. These are my connection types. Now I can have this beam to beam connecting two hollow sections. This can be my task, that I want to connect two hollow sections, right? Or in this beam to beam, I can have two I sections that I want to connect. Are you getting the point? Similarly, in the beam to column connection, I may have a box section and I want to connect, let's say, a I section beam to this. Okay. So connection types will be these, but depending on the member that we want to connect, our strategy may change. Are you getting this point? Okay. So therefore, we will be discussing all these connections, all these connection types that we have. This we will be discussing for different types of members. So I will be taking a three plate section, hot rolled channels, angles, hollow sections. Hollow sections are actually slightly complicated when it comes to connecting them. And we will also discuss what to do for pipes, circular pipes. So we will be taking different member sections and we will also discuss, or special focus will be given on the commonly used connection typologies in actual structural steel project. What does this connection typology mean? So it means that there are some standard connection types that we adopt in our regular projects. Okay, so we will have special focus. uh, our discussion will specially focus on the commonly used connection typologies. Just to give you an example, if it comes to a beam to column rigid connection, where beam and column are made out of plate sections, a very commonly adopted connection typology is the extended end plate connection. Okay, in most of the PEB structures, you see this type of a connection typology. So if this is the commonly adopted connection typology, we will pay special focus on this, because if you go to any actual project or if you do any actual design, you will come across or you will be asked to develop, design this type of connection. So we will pay special focus on the connection typologies that are often used. Okay, then which standards are we going to refer? So the standards that we are going to refer to will be standards that we are going to refer will be, of course, IS 800 2007, because this will be the basic standard for us in the Indian context. We will be referring to AISC 360 also. This is the American code, and these have some good documents and handouts that they have, handbooks that they have. So we will be referring to this also, and we will be referring to the Euro code 1993 Part 1 Section 8. So these will be the standards that I will be referring to. Okay. Good. I hope this is clear. Okay. Now going back to my presentation, and I'll just quickly now move ahead, and then we can address all your queries. So actually I had to move to a different presentation because that particular presentation I saw that it was not having some items. Yes, and we have also included, after getting the input from the participants, a few things about the anchor fasteners. So this will also be a part of our course content, where we are going to discuss anchor fasteners. What are anchor fasteners? Anchor fasteners means, in an existing RCC you put this anchor fastener and then you connect your steel member to it. So this is also what we will include in our discussion. I have already covered this slide. What are going to be the features? So live sessions we will have between morning 8:30 to 10:30 a.m. The course can also be taken as self-paced learning course. That means participants who are unable to watch it live can watch the sessions online on our portal as per their convenience. So, in the self-paced program, or for all the participants, the course will be valid for a period of 8 months. Uh, we will also, of course, all our discussions will involve some live examples of relevant cases of industry practices. We will include that in our discussion. That is quite obvious. We will, of course, we emphasize a lot on asking questions. So we encourage participants to ask questions, and we'll try to solve your doubts, try to address your problems individually. That will also be done. And also, for the participants who are going to not be able to attend live sessions, we will have some mechanism where we can conduct, let's say, one session every 7 to 10 days on a weekend. Okay, so on a weekend we will conduct one session where the participants who are not able to interact with us during the live sessions, they can join, and they can discuss whatever they have, whatever doubts they have in live. So these are going to be the features. Who will benefit? So fresh graduates. So this course should not be taken by students who are pursuing their engineering. So for this we expect a minimum engineering graduation to be completed in civil or structural engineering. So fresh graduates, postgraduate students in civil structural engineering can take up this course, and they will have a lot of benefit. Consultants or engineers who are seeking job or wanting to start as consultants, engineers having 1 to 5 years experience wanting to skill up, or experienced structural engineers who want to deep dive in this uh, aspect of connection design, or of course anyone who loves structural engineering and wants to learn more. So the course outcome, what is going to be the course outcome? Very important. This is one question you should always ask whenever you participate in uh, anything, that what will be the outcome. Okay, what is the expected outcome? So the desired outcome after the completion, this is what we expect, that after completion of this course, these should be the outcome for our participants, and the participants should also expect this out of us, that if you are going to involve time and effort and money for this course, these should be the outcomes. So we expect that the participant shall develop in-depth understanding uh, of structural steel connections for different member types. The participant should be able to operate this software and understand the complete process of connection design using it. The participant should be able to understand, create, and use custom made MS Excel spreadsheets. Okay. So this custom made, what is very important, we don't want you to use any Excel sheet that you don't understand. We will always encourage you to first be able to make an Excel sheet and then use it for your designs. So we expect, and you should also expect, that the participant after the course completion should be able to create and use Excel spreadsheets for connection design. Of course, we will not be able to make connection. We will not be able to make Excel spreadsheets for all type of connections, but for some important connections which can be easily done manually, also we will develop some Excel spreadsheets. And lastly, we expect, and the participant should also expect out of us, that they will be able to develop. Imagine, very important. Imagination is very important when it comes to connection design. Detail and design complex connections using the software and use them for the day-to-day structural steel projects. So these are the desired outcomes that we expect out of the course. How to proceed ahead? Uh, After today's session, we will share a response form on the groups or on your emails, whatever, and you can indicate your preference whether or not you want to join this online course with us. If you want to join, the course fee is rupees 4750. So we actually believe in not keeping very high course fees. Many of our participants tell us to increase the course fee, but we think that instead of making higher course fee, it is better to keep a lower course fee and try to connect with more participants. So that has been our philosophy actually over the years. So this will be the course fee, and the method and detail for payment will be shared separately. So there are different modes of payment available. We'll share the details with those who are interested in joining. And then after completion of payment, we will add you to another WhatsApp group, which will be a course specific WhatsApp group for further updates, and the links for daily live sessions and any other info will be shared on that course WhatsApp group. So when are we going to start? Very important. So we will start from 16th January 2023, Monday, from 8:30 a.m. So today is 31st December. We will start after 2 weeks. Why this gap? Because there are some things that are still to be done. So we will do that. We'll complete them first, and then we will start from 16 January. So our course live sessions start from 8:30 a.m. 16th January 2023. Good. Now, before we move to your queries, let me just answer some FAQs, frequently asked questions that you may have in your mind, so that our entire discussion becomes simpler. So, a common question that many of our participants have, that you are a working professional, how can I join this course? So, if you are a working professional, you can join us as a self-paced learning course. Okay, you can join this course as a self-paced learning. So every session, when we conduct it live, within a couple of hours we will upload it online on our portal. Okay, and the participant can watch those sessions online as per their own convenience. And as I said, we will organize some periodic discussion sessions and interactions for those participants who are joining us as joining the course as a self-paced program. So we will develop some mechanism, maybe every fortnight or every weekend. We will try to organize some discussion session for the participants who are joining this course as a self-paced course. From where to get this idea Statica software? This is another question that we are often have been asked. So this idea Statica software, you can get it easily. Anyone can download the trial version of the software from the website of Idea Statica, and I have mentioned this website over here. So you just have to put your email ID and you are able to download the software. If it expires, you can just download it from another email ID. Okay. Good. So thank you for patiently listening. We had estimated the session to go for 35 minutes, but it has, I think, extended to around 50 minutes. So sorry for that. And thank you for patiently listening. And now we are open for any queries that you may have. So any queries, any doubts, any points for discussion you have, now you can ask. Yes, what are we envisaging? We are looking at some 30 hours, sorry, 30 sessions, and we are looking at some 60 hours of discussions in our course. So it's not a 5 hour, 12 hour, 20-hour course. It's pretty long that way. It's a 60-hour course because we think that what requires time requires time. Okay, you cannot. Uh, I mean, you cannot complete discussions in 12 hours, 20 hours. That is just. I mean, that has no meaning in our opinion. So you require time, you require effort, you require commitment. So minimum we will have 30 sessions. If required, it will extend more also. And those who have been our participants know that whatever number of sessions we say, we finally end up having more than that. Okay. Right. So this is what I had to say. If you have any questions now, we are open to answering your questions. So Mr. Kashyap is saying if we want to make zero axial force transfer to column from beam. Kashyap is saying if we want to make zero axial force transfer from column to beam. So I think he is talking about the portal systems. In portal system, what happens that your beams also undergo, or they also have some axial forces because of this portal action. So he's asking that he does not want any axial load to be transferred. So you make a shear connection, then complete pin connection you try to make. Then you will see that no axial load is transferred to the beam. Okay. Okay. Ravi is asking, can we connect tube column to tube beam? Yes, we can do that. So for connecting tube column to tube beam, tube column means hollow sections. So for connecting hollow sections, if this is my plan view and this is, let's say, a hollow column, if I want to connect another hollow section with this, there are different ways, multiple ways. One way is to have a flange plate like this, is to have a plate like this over here. So in elevation it will look like this, that this is my column, hollow column, and I have a plate, and on this plate I connect the beam. This is one way of connecting, of course, and here I can develop some bolting or welding, whatever. So the bolts will be over here. Right now they are obstructing the wall, but that can be managed. This is one type of connection possible. The other type of connection can be that if this is my column and if the beam is slightly smaller, I can have some connection like this. So I can place some cleat member like this, and then using the cleat I can connect it. So the connection will look something like this, that I have a cleat member over here and I connect my beam like this. This can be another connection type. The third connection type can be that I can introduce some side plates. So if this is my beam and this is the column in plan, I can introduce some side plates like this, face plates. So in elevation, this will look something like this, that I will have a side plate. This is my side plate, and then this is my member. Okay, so you can connect hollow section to hollow section, and of course there is of course this way of just welding it, butt welding it together. So you just weld your beam to the column through butt welding. So I think these are the connection types that come to my mind. Yes, Mr. Anshul is asking about long slot holes. So I think he is asking about the slotted holes that we give for developing a roller action. So so we will do that. There is, I think, an option available in the software Idea Statica. They have the options for creating slotted holes also. So doing slotted holes will be difficult to do manually. I will tell you why, but we will try to do it on the software. Okay. Hardik is asking, can we have beam width more than column on which it is resting? Yeah, you can have that. Yes, you can have that. So let me just show you how you may be able to develop a connection for that. So I'll just continue with the same hollow section case. I'm showing the plan view. So let's say this is my column in plan, and let's say this is my beam in plan again, and you will notice that the beam width is larger than the column width. So how to connect it? So actually you can introduce a connecting element at the back like this. Okay, you can introduce a connecting element at the back like this, and then you can introduce some plate element like this, and here you can develop some connection assembly. Okay, this is the plan view. So yes, you can develop. I showed it with an hollow section. Same thing can be done with other connection types also. So it becomes slightly complicated, but can be done. Okay. Then Mr. Abdul is asking, how are we going to design connections? I mean, importing from other softwares also. Right. So in designing connections, see, in designing connections, you should have an analysis model with you, correct? You should have an analysis model. That means there should be some ready-made, let's say a STAD model that you have, or an ETABS model that you have, which you have prepared. So let's say this is my model. Okay, this is my model, and now you want to develop this connection. So you first run your analysis and in any of this software, and now you want to design this connection. So if you want to design this connection, either you take it to a connection software, or you do it manually, or you note down the member forces and take it to the connection software. Okay, so the member forces, either you take it to the software, connection software, so you export it to the connection software, or you note down the member forces and take it to the connection software, or you do the connection design manually. Okay, so for example, you are doing a RAM connection software. So RAM connection, because it is a product of Bentley, it has good compatibility with stat pro, so very easily you can take the member forces and you can develop easily a connection in RAM connections. If you are using Idea Statica, there are some plugins that you have. There are some plugins that you have which you can uh, which you can use as an add-on for STAD or ETABS. So there are some plugins for Idea Statica. Because Idea Statica is a third-party software, it is not developed by Bentley or CSI. So there are some plugins available. Those plugins you can add on to this software. Then after you run your analysis, you select the member and you click on that plugin, and then this member is taken to the Idea Statica software. Okay, I personally don't uh, like this plugin stuff because then there are a lot of complications that are involved. So personally, I like to note down the member forces. You note down the member forces very easy, and you take it to the connection design software where you first model the connection yourself and then apply those member forces and then design. Personally, I like that way, but there are options to export a particular member connection to software also. See, when it comes to connection design software, you are not going to take the entire model, try to understand. You are only going to take a connection with you. All right. So those options are available. But personally, if you ask me, I like to note down the member forces and then take it to the software, model the members first in the software, develop the connection, apply the forces, and then do it. Yes. I hope this answers. Mr. Anshul is asking diaphragm plate movement connection will also be covered. What is a diaphragm plate? I'm not quite sure what is a diaphragm plate. Oh, let me just put it on the internet just to see what is the meaning of diaphragm plate. AIP diaphragm plate movement connection. Uh, oh, okay. I have this connection I am seeing for the first time. Yeah. So let me see. We will be able to model it, of course. Yes, we will try to do it. Quite interesting. Diaphragm plate moment connection. I just searched on the internet. We'll try to do it. Okay. Then Anshul is asking tube column to beam connection. Isn't the connection complicated if we flush end plate to tube column face? I generally provide end plate connection 300 away from tubular column face. Yes, it is complicated, but uh, yeah, you have to do. So Anshul is he's saying I think that if this is his column, hollow column, then what he is trying to say I think is that he will provide a beam stub and then he will have a connection over here and then he will connect the beam like this. Is that what you wanted to say? If I show this in elevation, so I think what he is trying to say that he will create a stub. He will have a, let's say, a flange plate, and then he will bring this beam and connect it over here. I think this is what you wanted to say. Yes. Okay. Right. So yeah, I think this is good way of doing it. So this is my beam, and this is my column, and this is the stub that he has provided, and these are called the flange plates. So you can do it this way also. This is of course the plan view and this is the elevation. You can do it this way, or you may provide end plate on the face and do it whatever is more convenient. Okay. Okay. Yes, please type in your questions quickly. Whatever queries you have, you may feel that it's not worth asking, but still type in. There is no problem. Kashyap is saying if there are beams of more width attached to column on all four sides, then how to do that? Right. Then I think if you have such a situation, then I think you will have to create something like we just discussed right now. I'm taking hollow sections. Let us take an I section. If you have a wider beam and if you want to connect it, and he's saying you have wider beam from all sides, so then you have to stop that beam somewhere over here by providing some end plates. You will have to stop it. Okay, that needs to be done because if you take it to the column, suppose I have a hollow section, if beams are coming, wide beams are coming from all four sides, you have to stop it before. Yes. Then uh, Mr. Abdul is asking, outrigger truss to mega composite column connection will be discussed. I'm not quite sure how this connection looks like. If you have any details, you share. I'll see. Okay, Anshul is clarifying about the diaphragm plate connection, and we have to provide where end plates cannot be provided. Yeah, I'll actually study more about it because I had never heard about this name before today. So I'll see and read more about it, and then I'll come back. Maybe we will take this discussion during the course. Uh, Mr. Alek is asking, do we use ETAP software? No, so the software I will be using for connection design will be the Idea Statica software. But if we require the member forces, because of course we will require member forces for designing those connections. So to take the member forces, we will take the member forces from STAD and ETAPs. Okay. So some models I will take them from STAD, some models I will take them from ETABS. So member forces from STAD and ETABS, but connection design will happen in Idea Statica. Clear? Idea Statica or Excel spreadsheets. Okay. Yes. Anything else? Yes. Abdul is saying that he will share the details of outrigger truss to mega composite column connection on the group. And yes. Okay. Ruchit is asking, yeah, he had asked me this question on LinkedIn also. I was not able to answer then. He's asking all for all the above mentioned connections, will we have a spreadsheet, Excel spreadsheet? Yes, you will see that for all connections, we might not require Excel spreadsheets, but if it is possible, for whichever connections we require, we will develop spreadsheets. See, you should understand that Excel spreadsheets we can develop uh, only for the general connections. General connections, what does it mean? General connection means that the connections that you are going to frequently use. Correct? So only for the frequently used connections, it is it is beneficial to develop an MS Excel spreadsheet. Otherwise, for every connection that comes to you, if you start developing spreadsheets, it does not make sense because some connections may be specific connections which you might not be using elsewhere. So it does not make great sense to develop Excel spreadsheet calculators for connections which you will not be doing in your regular projects. So Excel spreadsheets we will develop for the frequently used connections. Okay. How many of you know how to use Excel? Basics of Excel. I hope many of you understand the basics of Excel and MS Excel, and they are able to operate Excel. At least the basic commands are known to them. This much I am expecting from our participants. Okay. Yes. Good. So anything else? Any other question? Alek is asking, do we do built-up connections? Built-up connections. I think he is saying that if I have plate sections, I think so. Then connection between these plates. Is this what you mean by built-up connection? Or built-up section connection? Oh, sorry. Okay, okay, yeah, 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 yeah. Of course, we will do. Built-up section means sections that we create out of joining two or more elements. So suppose I have a member like this, laced column or laced column like this, batten column, this connection with some other member, we will do connections for this. Yes, yes, we will do. I mentioned it in the start, at the start. Mr. Ritvik is asking, is Idea Statica open software? No, it's not an open software. It's a licensed software, but you can download the trial version from their website. And for students and for educators, they have some good features available on their website. You can download the trial version by entering your email ID. If that trial version expires, you can just put another email ID and download it. Okay, so it's a licensed software, and you have got perpetual licenses as well as rental licenses available. There are good lot of good tutorial videos on Idea Statica there that are available on the YouTube. So to get a basic understanding of the working, you can look at those YouTube videos. Of course, it does not give you the structural understanding that we will have during our course, but it at least helps you to get operational understanding of the software. Okay. Yes. Anything else? No. Okay. So I think we had a good introductory session, and you have understood what will be covered in the course. So we will start this course from 16th January 2023. This is when we start our live sessions from 8:30 a.m. So in case you have any other query, you may connect with us on social media, or you may connect with us on the LinkedIn or WhatsApp, over whichever medium you want to connect. You can connect with us. Okay, so that is all we have. Thank you. Have a good. Oh yes, I should have answered this. Let me just answer this question. So Anshul is saying chemical fasteners, Hilti. Yes, so I had mentioned the use of fasteners. So mostly fasteners mean that you have an existing RCC structure or any existing RCC member. On that, if you want to connect anything, then we have to put fasteners. And mainly these days, the fasteners that you get are chemical based. That means you put some adhesive chemicals, and then you put your fastener. So a big company that comes to your mind is actually Hilti. Okay, so Hilti is a big manufacturer of anchor fasteners. So these have their own software, and they are freely available software that you can download and use. So it's not a paid software by Hilti; it's a free to access software. Okay, all right. Alec is asking, do we use Idea Statica in detail? Of course, in great detail. We'll see the workings of the software in great detail. It's a finite element based software, so they call it as the component based finite element method. It actually depends a lot on the mesh sizing and mesh convergence, and there are a lot of those issues. Okay, so we will discuss Idea Statica in great detail. Mr. Abdul is asking, how about SDC courses? How about SDC courses means? Okay, so you asked this question. I'll answer this on a separate platform, not now. Uh, Jaisal Munir is asking, is it possible to start timing from 7:30 a.m.? I think it will be early for. Uh, Earlier, we used to start actually at 7:30 a.m. I hope you are saying AM, not PM. But we used to start some courses. We started at 7:30 a.m. also, but then we got a feedback that it's too early, so then we shifted it to 8:30. But some courses we have started at 7:30 also. Actually, in India, we start our work late. If you go to if you go to European American countries, of course they have problem of evening light also. Uh, of course they have problem of evening light, but I have seen that things in Europe, America, even in Eastern Asian countries start quite early. So everyone starts their office at 8 a.m., 7:30 a.m., and they finish their work early. So they are home by 4:35. We in India, I don't know why we start our work at 11 and continue working till 8 9 p.m. Anyway, so yes, Mr. Abdullah is asking about the SDC Steel program. Yes, drop a message. Drop a message. I'm not putting a link over here because this is a presentation for a different course. Okay. So I think we have been able to understand this quite well. For more updates, if you want any further update, you can join the you can fill this form and you can join the WhatsApp group to get further updates related to this course. I'm putting a link in the comment section over here, so you can just fill in the form and you can join this group. As I said, we are going to start from 16th of January 2023, 8:30 a.m. Okay, so I hope all of you will join this course and we will have a great time learning. That is all what we have for this session today. This also marks the end of year 2022. So I wish everyone a great uh, new year 2023 and hope that you are able to maintain good health and this 2023 uh, proves to be a prosperous and a healthy year for you. So that is all. Thank you. We will meet you on 16th of January where we will start our course. For any further updates, you visit the website or you click on the link that I have put in the comment section. So that is all. Thank you for joining on a weekend. Have a good weekend. Party hard. So, and start the new year on a good note. That's all. Bye bye. Thank you.